We have seen the various forms of operations of matrix. We've seen the addition, we've seen the subtraction, scalar multiplication, and matrix multiplying by matrix. Now, let's consider the types of matrices. We have the square matrix. This one is a kind of one that has an order of m by m matrix. So it can be 1 by 1 matrix. Okay, it can be 2 by 2 matrix. It can be 3 by 3 matrix. It can also be 4 by 4 matrix. So these are square matrix. The 1 by 1 matrix, we can just say this is 1. A 2 by 2 matrix example is 1, 2, 3, 4. Right? And a 3 by 3 matrix example can be 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see 3 rows, 3 columns, just as we did the start of the video. And an example of the 4 by 4 matrix can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So this are examples of square matrix. Same number of rows, okay? Number of rows as a key is equal to the number of columns. Now, a diagonal matrix now. A diagonal matrix is a square matrix, all right? So in short, a diagonal matrix are 1 by 1 or 2 by 2, 3 by 3, and the likes. First, a square matrix with all elements 0 except those on the leading diagonal. Now the question is, what is the leading diagonal? So if I have a square matrix, let's say A11, A12, A21, A22, and likewise I have A11, A12, A13, A21, A22, A23, A31, A32, and A33. Now the leading diagonal is starting from the top left downwards. All right, leading diagonal. So in the same way, leading diagonal. Now it now says a square matrix is with all elements 0 except those on the leading diagonal. So I can have all zeros except those on the leading diagonals. I can say 2, 5, 2, 5, that's the leading diagonal, and the remaining 0. And likewise I can say 2, 5, minus 3, and the rest 0. So this is a diagonal matrix. All elements are 0 except those on the leading diagonal. Now we have also a unit matrix. Now a unit matrix is a diagonal matrix in which all elements on the leading diagonal are all unity, and all unity here means that is equals to 1. So first of all, it's diagonal matrix. So a diagonal matrix is a square matrix, right? So we have 2 by 2 matrix. All right, so let's first put the examples that we had before. We had 2, 5, 0, 0 is a diagonal matrix of 2 by 2, and for a 3 by 3 matrix, let's say we have 2, 5, I think minus 3, 0, 0, 0, 0, 0, 0. Now this is a diagonal matrix, but however, a unit matrix are elements in which all elements of the leading diagonal are all unity. So instead of having 2, 5 here, it will be 1, 1. Instead of writing 2, 5 minus 3 here, it will be 1, 1, and 1. Now the diagonal matrix here are sometimes denoted as I. Yes. So it can also stand as identity matrix. Unit matrix, identity matrix, they all work the same way. So they say write the unit matrix of a 2 by 2 matrix. So we'll have this, and the unit matrix of a 3 by 3 is this. And finally, for this video, we have a null matrix. A null matrix is one whose elements are all zero. Now this one doesn't have a dimension constraint, so it can be a 2 by 2 in which all the elements are zero. It can also be a 2 by 3 in which all the elements are zero. Okay, and it is always denoted as 0. So I can say this is equals to 0 and this is equals to 0. So this is a null matrix. I can have 3 by 3 matrix in which all the elements are 0, and this is called a null matrix. So in the next video now, we'll learn about transpose of a matrix, and then we'll see how to incorporate transpose of a matrix into simple matrix operations.